Hello everyone. So we are now in quarter 1, module 3, lesson 3, standard equation of an ellipse whose center at C, the coordinate of HK. So we have here the learning competency. Determine the standard form of equation of an ellipse. The objective, determine the standard form of equation of an ellipse whose center at C, the coordinate of HK. So we have here the concept notes. Standard equation of an ellipse in her horizontal form whose center is at C, coordinate of HK. Let C is less than A but greater than 0 and B is equal to the square root of A squared minus C squared, an equation of an ellipse whose center is at C, the coordinate of HK, with foci at F1, the coordinate of H plus C, K, and F2, the coordinate of H minus C, K, and the vertices at V1, the coordinate of H plus A, K, and V2, the coordinate of H minus A, K. Okay, remember that if the value of K is the same and the value of H or the value of X is increasing or decreasing or changing, so that equation or that ellipse is a horizontal, and the equation of that ellipse is the quantity of x minus h squared over a squared plus the quantity of y minus k squared over b squared is equal to 1. Okay, so we have here another equation of an ellipse if an ellipse is a vertical. Okay, so we have here the foci or the F1 is H, then K plus C, and the F2, the coordinate of H, K minus C, and the vertices at V1, H, K plus A, and vertices 2, the coordinate of H, K minus A. So if you look at the given, the foci and the vertices, so the value of each is the same, while the value of K is either increasing or decreasing. So if the value of K or the value of Y in the coordinate is changing, so it means that this graph is a vertical or this ellipse is a vertical. So the equation of this ellipse is the quantity of y minus k squared over a squared plus the quantity of x minus h squared over b squared is equal to 1. Okay, so we have here an example. Find an equation of the ellipse having vertices at -3, -4, and 7, -4, and whose minor axis has a length of 4. So if you look at the given, the vertices, which is -3, -4, and 7, -4. So the value of h is changing, and the value of k still remain. So it means that this graph is a horizontal. Okay, then after that we are going to solve the value of a, since the value of a is from the center to the vertex of major axis. Okay, so remember that the given is the end point of the vertices. So when we are going to find the value of a, it becomes 2a, because the length of the center to the vertex is a, since the given is vertex to vertex, so it means that it is 2a. Okay, so we have here 2a is equal to 7 minus 3, and 7 minus 3 is equal to 10, which is 2a is equal to 10. And we are going to divide at both sides of the equation by 2. The result is 10 over 2. Then the value of a now is equal to 5. Then we have already the value of a. Then from the given on the problem, whose minor axis has length of 4. So it means that the co-vertices, the length of the co-vertices from one point to the end point, or W1 to W2, the length is 4. So meaning that is 2b, because the value of b is from the center to the minor axis, or to the co-vertices. That is the value of b. Since the given is W1 to W2, so meaning the end point of each minor axis, so it means that it is 2b. So solving for b, we have 2b is equal to 4. Then divide it by 2, the result is positive 2. Okay, so you have already the value of a and also the value of b. Now we are going to solve the center of an ellipse. Okay, since the given is the vertices, or the vertex 1 and the vertex 2, we can solve now the center of an ellipse using the midpoint formula, where c is equal to x1 plus x2 over 2 and y1 plus y2 over 2. Remember that our x1 is negative 3 and x2 is positive 7, while y1 is negative 4 and y2 is also negative 4. Okay, so we have here now negative 3 plus 7 over 2, and the value of y is negative 4 plus negative 4 over 2. Okay, so negative 3 plus 7, that is positive 4, divide 2, and for the value of k is negative 4 plus negative 4, the result is negative 8 over 2. Okay, so therefore the value of the center, or the coordinate of the center of an ellipse, is positive 2 and negative 4. Okay, then solving for the equation of an ellipse, since you have already the value of the coordinates, the value of a, and also the value of b, we have here, using the formula of horizontal, or ellipse which is horizontal, which is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. Okay, substitute the value of h and the value of k. Since the value of h is 2 and the value of k is negative 4, and the value of a is 5, and also the value of b is also 2. A substitute, it becomes the quantity of x minus 2 squared over the quantity of 5 squared plus the quantity of y plus 4 squared over 2 squared is equal to 1. Okay, then simplify. We have here the quantity of x minus 2 squared over 25, because 5 squared, the result is 25, plus the quantity of y plus 4 squared over 4 is equal to 1. Okay, so that is now the equation of an ellipse, which is a horizontal ellipse. Okay, so we have here another example. Find an equation of the ellipse whose center is at 2, 7, having the focus of 2, positive 10, and having an endpoint of each minor axis at 4, 7. So we have here the solution. Since both h, which is equal to 2, or the value of h for the center and the focus is equal to 2, so therefore this ellipse is vertical. Okay, so solving for the length of c, remember that to find the length of c, that is from the center to the focus. Since the given coordinate of the center is 2, 7, and the coordinate of focus is 2, 10, so we will refer to the value of y to find the value of c, since this is vertical. So we have here c is equal to 10 minus 7. So the result is equal to 3. Then we are going to solve the value of b. Remember that to solve the value of b, that is from the center to the minor axis, or to the co-vertices, which is w. Okay, so since this is a vertical, so we will refer to the value of x. Since the center is 2, 7 and the coordinate of the minor axis is 4, 7, so we will refer to the value of x, which is 4 and 2. Okay, so we are going to subtract the result of 4 minus 2 is equal to positive 2. So you have already the value of C, which is 3, and the value of B, which is 2. So now you can solve the value of A. Okay, solving for the value of A using the formula of B squared is equal to A squared minus C squared. Okay, substitute the value of B, which is positive 2, or 2 squared, is equal to A squared minus the value of C, which is the quantity of 3 squared. Okay, so 2 squared is equal to 4. Then the value of C is 3 squared. So we have here 4 is equal to A squared minus 9. Then combine all similar terms. It becomes 4 plus 9 is equal to A squared. Then after that, we are going to add 4 plus 3. The result is 13. So A squared is equal to 13. So to find the value of A, we have to extract the square root of both sides of the equation so that we can cancel the radical and the exponent. So we have to extract the square root of A squared is equal to the square root of 13. So we can cancel the radical and the exponent. So the value of A now is equal to the square root of 13. Since you have the value of A and the value of B, and you have already the value of C, using the formula of an ellipse, which is a vertical, where y, or the quantity of y minus k squared over a squared plus the quantity of x minus h squared over b squared is equal to 1. Substitute the value of h and k, where k is equal to 7 and h is equal to 2. So we have here the quantity of y minus 7 squared over the square root of 13 squared plus the quantity of x minus 2 squared over 2 squared is equal to 1. Okay, so to simplify, we have here y minus 7, or the quantity of y minus 7 squared over the square root of 13 raised to the power of 2. We can cancel the radical and the exponent. So the remaining values is 13 plus the quantity of x minus 2 squared over 4 is equal to 1. So that is now the equation of an ellipse. Okay, so we are now in Watch More. So this Watch More is the exercises. So the exercises stated that find an equation of the ellipse with the following condition. Okay, so the first condition, the center is 5, 3. Horizontal major axis length of 20. So it is stated that it is a horizontal major axis. So the vertex is horizontal. So meaning this graph is a horizontal ellipse. And the minor axis of the length is 16. So it means that we will use the formula of a horizontal ellipse. Okay, next, major axis of length 12, center of -2, -9, and the focus at 3, -9. Okay, so if you look at the given, the center to the focus, so the value of x is changing while the value of y is still remain. So it means that this graph is a horizontal. So you will use the formula for horizontal ellipse. Number 3, having a vertex at 3, 7 and a foci 3, -1 and 3, 5. Okay, so you are given the vertex and also the endpoint of 2 foci. So since the vertex and the foci, or the focus, one endpoint of the focus is the same value of x and different value of y, so it means that this graph, or this ellipse, is a vertical ellipse. Number 4, minor vertices, -4, 8 and 10, 8. So meaning the vertices minor, so W, the major or the minor axis. Okay, so since the value of x is changing but the value of y is still the same, so this ellipse is a vertical. Again, this is the minor is changing. So, okay, so that is now your exercises. Okay, thank you for listening and do not forget to subscribe my channel.